Lesson 4.4, page number 285. Name of this section is Linear Equations in One Variable. What we've been doing is linear equations. Any of the problems we've done with equal signs, if we have them written as complicated as negative 3x plus 4 equals 12, it's called a linear equation. And the reason it's called a linear equation is because if you were to draw a picture of this equation, you would get a straight line. So one of the things we'll be doing later, and you'll be doing in more advanced math courses, is graphing these, or drawing a picture of what the equation looks like on a graph. So that's what they mean by linear equations, is any equation that if you were to draw a picture of it, you would get a straight line, compared to a circle or a curve or something along those lines. So 4.4 is basically review of what we did in the last section, with a couple tweaks in there just to kind of add some challenge to it. But we're just going to continue on with 4.3 into 4.4, and you should be just fine with it. But we're going to use some equations that are going to take a little bit more information that you've learned in the past. You're going to have to remember a lot of the old stuff. This particular one, you're always keeping PEMDAS in the back of your mind. Parentheses, exponents, multiplication, division, addition, and subtraction. Keep that in mind as you're doing this. Do all of that stuff first as you're going along. Well, parentheses can't do anything there, so remember we do the distributive. Now we get rid of a number added or subtracted to the x by doing its opposite. And we get 3x equals negative 9 minus 6 is negative 15. Then we get rid of the number multiplied by the x, in this case 3. Those go away, and we get x equals negative 5 when we divide through. So that's an example of what we're going to be doing in this lesson. We're going to get a little more challenging as the examples go through, but you should be fine. In fact, let's try one right now. I'm going to leave that as an A. Okay, plus 5 equals 2a minus 7. Now, there are several ways to do these math problems, and if I'm doing them different than the book, it's just because there's a lot of different ways to make this work. It depends on how you were taught and how you have been teaching it over the years. And so I'm going to stick with the standard way that I was taught how to do this, and it seems to work for me. But if you like the way the book does it, go ahead and do that. One of the things that I taught you in the last section is what you're trying to do. Your ultimate goal here is get the variable isolated, the letter isolated on one side of the equal sign. Well, the problem that we run into here is we have an A here and an A here. We have A's on both sides. So what we have to do is we have to get this 2A over here, or this 4A over here, so that they're together. We can't have them apart like that. So what I would suggest doing, and it doesn't matter what order you do this in, is first of all, let me underline real quickly my like terms. My like terms are those groups of numbers separated by a plus or a minus sign. So I have 4 terms up there that I have to manipulate. And the reason I underline those is because this 2 and this A are together. This 4 and this A are together. Whatever I do to the A, I also have to do with the... I mean, these are stuck together. We're not going to pull them apart. So this is 2A. It isn't necessarily just 2 times A, although it is. They're stuck together as 1, just like the number 3. You can't separate 3 into anything. We're not going to separate these. We're going to look at them as one unit because they're one term. And I go through all of that just to say that when we start moving things around, we're going to move the 2A as one unit, or the 4A as one unit. We're not going to separate those yet. Remember, we do the multiplication times the variable and get rid of the number in front of the variable, and it's multiplied is a last step. So we just drag that 2 and that A together, or the 4 and the A together, wherever we happen to go. So anyway, we're just going to pick which A we want to isolate. I usually suggest the larger number in front of the A, leave that alone, and move everything else. So in this case, my largest number in front of the A is the 4A. So let's leave that there, and we're going to start moving some stuff around. So right here we're going to get rid of the plus 5 because again we're trying to get this 4a by itself. So let's get rid of the 5. And I usually put the minus sign under the number I'm going to subtract it by. Okay, so now I have the 4a isolated. Problem still remains, I've got a 2a over here that I need to get over here so that my a's are on the same side. Always the case. Your ultimate goal is to get all the a's on the same side. So, what sign is in front of this 2? Well, if there's no sign, if there's not a minus sign, there's obviously a plus sign. So if I were to get rid of 2a with a plus sign, just like I did up here with a plus 5, how did I get rid of a plus 5? I subtracted 5. How do I get rid of a plus 2a? I subtract 2a. Which means I do it to both sides. So 2a minus 2a disappears. 4a minus 2a is 2a equals negative 12. Now I'll let you look at that for a minute and see what I did. I didn't separate the 2 and the a. I left them together, and because this was a positive, because it didn't have a sign, I assumed it was a positive to get rid of it. That's what I'm trying to do, is I'm trying to get rid of it so that this 12 is by itself. And by getting rid of it here, it drug over here. Okay, so now I have a 4a minus a 2a here, and I have a 2a. Now I can divide by 2. Remember, the last step is to get rid of the number added or multiplied by the variable. And I get a equals negative 6. And if I put a negative 6 up here, those two would be equal. Negative 6 times 4 is negative 24, plus 5 is negative 19. 2 times negative 6 is negative 12, minus 7, also negative 19, so it does work. Alright, we'll do a few more of those, just because they're a little bit tricky sometimes. In fact, let's do example 4 on page 286. See if we can get through this before my video runs out. You can only put 10 minutes of video on YouTube, so every 10 minutes I have to start the video over. So I'm at about 8 minutes now. Alright, so can't do anything inside the parentheses, so we distribute. Okay, combine like terms. Okay, the variable with the biggest number, I'm going to leave that alone. Try to isolate this whole thing first before I try to isolate the x. So I add 17 to both sides. So I get 10x equals 4x plus 12. Now, again, the sign here in front of my 4 is a positive sign, so to get rid of it, so I can get my 12 by itself, I do that to both sides. And I get 8x equals 12. Okay, not real pretty if I wrote everything down right. Let's see. You see any mistakes that I made up there? Maybe I wrote the problem wrong. 4x minus 5. No, got that one right. I've got a mistake in here somewhere. Let's see if I can find it. 6x. Ah, there it is. 10 minus 4 is 6x. Silly me. Alright, so even the instructor screws up regularly, doesn't he? Alright, so now that I have 6x equals 12, I divide both sides by the 6, and I get x equals 2, which is the answer I want. Alright, so we're going to go on with a 4.4b, so go ahead and turn this off and get ready for the next part of this.